Hello, this is a Reconstruct tutorial video brought to you by Dr. Kristen Harris's lab in the Center for Learning and Memory at the University of Texas at Austin. In this video, I'll be demonstrating how to first identify a dendrite on an electron micrograph, how to follow it through the neuropil, how to identify its protrusions, and finally, how to trace a dendrite and its corresponding protrusions correctly. As always, we will begin by opening up the series by going to the series drop-down menu. From here we will select Open, and you'll need to go to the correct folder on your computer that houses the .scr file for the project you want to work on. In my case, I'm already in that folder, so I will go ahead and select the .scr file, click Open, and when I do that, as you can see, the electron micrograph images in this series open up in Reconstruct. And now I can begin to work on tracing my dendrite. But before I show you how to trace a dendrite, I'm first going to show you how to identify one on an electron micrograph. This particular series was taken from the hippocampus of an adult rat, and the structures may look a tad different if you're dealing with developmental tissue, but overall these tips should help you be able to identify a dendrite in whatever tissue that you work with. To better navigate the series images, I'm going to go select the pan and zoom section tool, which is on the top of the toolbar, second from the right. And this tool allows me to zoom out if I move my mouse forward when right clicking, and to zoom in if I move my mouse backwards when right clicking. Also, if you left click, you can move the series image in any direction you want, so to the right, left, up, and down. So you have your electron micrograph image in front of you, and there are all these structures on your screen, and the question is, how do I identify what are dendrites and what are other structures such as axon and glia? Well, the first thing you can look for is both mitochondria and microtubules in the cytoplasm of your dendrite. So if I zoom in a little to better see these structures, this is a cross-sectioned mitochondria, and you can see the cristae inside the membrane. And microtubules are a bit harder to identify, especially if you have low quality EM images, but luckily these are very nice images to work with, and you can see microtubules as small circular structures that do not have a dark outer membrane. So this particular dendrite, if I zoom out a bit, you can see that it has quite a few microtubules. So here's one, here's another one, here's another one, and you'll get better at identifying these with more practice at looking at electron micrographs. But those are the two main structures that you'll want to look for when identifying a dendrite. Another way to identify a dendrite is by looking for dendritic spines that protrude from the dendritic shaft, which is basically this circular outline right here. And a protrusion, as the name implies, comes out from the shaft of the dendrite and extends until they generally make a synapse with an axon. Now you may ask, well, this structure down here also has mitochondria and what appear to be small circular objects like the microtubules. However, you will notice that these objects have a more heavily stained outer membrane, making them darker, and what these are actually synaptic vesicles in an axon bouton. So now that we have a general idea of what a dendrite should look like, I'm going to zoom out and identify a few more. So we have a dendrite right here as well. We have a third one to the right of that. And if we go back down to the left corner, here's a fourth dendrite. If you open up a series and none of the dendrites in the series are marked, then the standard method for identifying them in the Harris lab is to use this draw ellipse tool, and if you left click you can drag and make a circle of a desired size, and basically we denote a dendrite by naming it with a capital D and then starting with a number, so capital D01 for instance. However, say that you are working on a project that you have already worked on in the past and the dendrites have already been marked for you. There is an easier way to find that dendrite than by using the scroller to scroll through the sections and trying to locate it. You can go to the drop down menu under the objects and go to list objects, and basically all of the objects in the entire series will be listed here. And so say I want to go to D01 lowercase c. If I click find first, it'll take me to the first section that the object appears on. Notice that it did not take me to section 1, however, it took me to section 40. That is because the first section that this particular trace appeared on was on section 40. So if I scroll down to section 39, then you can see that the stamp is no longer on this section. For the sake of this demonstration, I'm going to be working with this dendrite on my screen, so I'm going to drag it to the center, zoom out a tad, and before I start tracing this dendrite, I want to go to the Trace Palette options to enter the correct names for my traces and P-stamps. I can do this by either going to the series drop-down menu and going to options, or I could have also pulled up this tab by using Control O, and it'll bring it up as well. Now, once you have the series options menu open, you want to go to names/colors tab. As you can see, there are a lot of trace options under this tab, and you can customize each one of these with a name and color by clicking on the desired icon and by entering the correct name. So this was D03C, and I personally like to trace with a yellow border. That's just personal preference. You can trace with whatever color you want. And generally I do not fill my traces. That is what this option right here is for. So I usually click none, although you can click darken, and that is useful when you are exporting electron micrograph images for figures in your paper. And I want to unclick this fill when not selected. That way, whenever I leave that section and the trace is not selected anymore, it will not fill the dendrite. So now that I have that trace done, I'm going to go to this triangle here, and I'm going to have this be my protrusion stamp, or P stamp for short. So I usually use red for these, and on these I do use solid and fill when not selected, because rather than a trace, I'm going to be using this stamping tool. So I need to name this correctly by going to D number, and that number corresponds to the number of your dendrite. In this case, I also had D03C. And then you want to put P, which stands for your P stamp, and we will start off using 01. And these numbers correspond to which protrusion you are referencing. Each protrusion you will use the same name stamp. However, once you come upon a second protrusion, then you would change this last number to 02. So now that I have all of my trace settings to the preferences I want them at, I can bring up the trace palette by going to the trace drop-down menu and going down and clicking on palette, and that brings the trace palette up here, so you have easier access to it rather than having to go back to the series options every time and clicking on the particular trace name and characteristics you want. At this point, you should have everything set up so that you are ready to trace your dendrite. And there are two approaches you can take to tracing your dendrite. The first one involves basically scrolling through the series and not tracing anything. And when you're doing this, you are searching for protrusions that come off your dendrite and stamping them with the P-stamp tool. So if I scroll through the series, I find a protrusion that connects. On section 42 it is not connecting, but then on section 43 it is fully connected to the shaft, and this is just due to how the protrusion was cut when making the tissue slices. And what we want to do is go grab and click our protrusion stamp, and we will click on the stamp shape tool on the top here, and we will denote the protrusion origin, which is where it first connects to the base of the dendrite, by stamping it at where the shaft of the dendrite connects to the protrusion neck. So I've stamped it there, and if I scroll up, I see that it's still connected, so I'll put another P stamp down. And if I scroll up again, it's still kind of protruding out right here. And at this point, the origin is probably gone. I could stamp it and then look at the 3D later and then decide whether to keep that protrusion stamp. I'll just go ahead and put it down for now. And the reason that I like this approach is because not only do I get a general sense of what the dendrite is like and where its protrusions are, but you also get to look at the dendrite without being focused on the plasma membrane. So sometimes when you're tracing, I generally like to be decently zoomed in. When you're tracing, you'll find that you kind of exclude things from your vision as you're following the dendrite membrane. And sometimes I found for me that this causes me to miss a protrusion, so I just like to keep a decently zoomed out view and scroll through the entire series, marking down protrusions. Now I'm going to scroll back because I actually did not stamp a protrusion. That was after the first protrusion I stamped. So some protrusions are easier to see than others. So this guy right here is also a protrusion, which you can tell on this section 46, and on section 45 you can also see that it's still barely connected to the shaft of the dendrite. But what I would do is I would go, and I'm going to use Control-O to go to my name and color options. I'm going to click on my P stamp and I'm going to increment it to P02. And for this demonstration, I'm just maintaining one stamp for my P stamps, but generally I'll make a whole row as all red triangles, so that way I don't have to constantly come back to the series options to change the name. But I will go here, and I would probably put the origin on section 44, the start of the origin. Yep. And stamp it on 45, stamp it on 46, and I would probably end the protrusion origin on section 46. The second way to go about tracing your dendrite is just to go ahead and hop on in, and if that feels more comfortable for you and you can identify the protrusions as you're tracing along the membrane, then by all means do that. So basically I just like being able to scroll through and mark the protrusions before I have to trace them. And sometimes I will find that I miss a protrusion doing that way as well, but then when I go back and start tracing, then I'll catch the protrusion then. So now I'm actually going to start tracing the protrusion. I'm going to zoom in a little. I'm going to go back down to section 40 where our dendrite started, and you can use one of two tools to trace the dendrite membrane. You can use this freehand drawing tool that allows you to move your mouse cursor and follow the dendrite membrane. I personally do not use this tool just because I do not have the steadiest hands in the world. And whenever you finish tracing the membrane, it automatically closes your trace. So for instance, once I get over here, it closes the trace for me, and there is the shaft of the dendrite traced. The other tool that you can use is the draw closed by point tool, and this tool you essentially click and extend your mouse, and then when you click again it creates another point and allows you to trace the shaft of the dendrite just by clicking from point to point. So this is the method I prefer to use, also because say I make a mistake and I start tracing all the way out here, which is not part of my dendrite. If I use the backspace key, I can go to the last point that I clicked at. So if I keep pressing it, I keep going back all the way until I'm back on the dendrite membrane, and I can continue clicking in a similar manner. So that is a very helpful function that is only available to the closed point-by-point trace, and you cannot do that with the freehand drawing. However, if you find that you make a mistake with the freehand drawing, what you can do is go ahead and use this clip, backspace, and retrace tool, so the scissors. And when you click on the trace, it will allow you to use the backspace function, and it goes in a counterclockwise manner. So if I backspace again, it goes to each point where I clicked in a counterclockwise fashion. So I'm just going to go trace that back up. And sometimes you'll find when tracing that you don't really know if you trace the membrane correctly. So another useful tool is this select domain image tool that has an arrow on top of what appears to be a neuropil. And if I left click using that tool, then it hides all of the traces on this section. However, you have to be very careful with this tool, because say you scroll up and then scroll back down, all of a sudden the image is gone. And you can get it back by right clicking, but it can be a pain sometimes. If you scroll up and click on something and then make a trace, then you can really mess up your image. So if you use this tool, always make sure to right click to make the trace appear again. Now I'm going to continue tracing the shaft of this dendrite, and I will opt for the close point-by-point tool, and I'm going to be a little sloppier than I normally would, just because I don't want to make this video too long for y'all. But there is a basically trade-off between speed and accuracy, and I generally tend towards accuracy, and that's also what Dr. Harris prefers as well. So I'll keep clicking, and notice that the protrusion starts coming out a little bit right there. So you start having this little bump from the dendritic shaft. And if I scroll up, I'll see that it's fully connected here. And generally when I come across a protrusion, I always trace it, but then I usually go back to where it's not connected, and you need to make sure to trace the rest of the protrusion as well. Otherwise, when you do your 3D reconstruction, your protrusion will look very flat, and it won't be a nice 3D model that you're looking for. So you can see now that I'm tracing just above the synapse, which is characterized by the dark staining on the membrane there, and it's also across from a presynaptic axon. So on this section, I now have my dendrite and its protrusion traced. So if I go up again, I can easily do this, and I'm going to go a bit quicker and a bit sloppier. That's because I want to show y'all how to make the 3D reconstruction that you'll be including in your lab reports, and if you work in the lab, potentially in a published paper. So we're going to continue. And if you ever are also confused by whether a structure is part of the dendritic membrane, you can always scroll between sections to see if you are tracing it correctly. So say I had traced this over here into the dendritic membrane. Well, if I scroll up, I can see that, well, there's still kind of this plasma membrane around here, and so that's a distinct structure. And if I go back down, it's also connected to this process up here. So that's how you can sort of identify whether something is part of your protrusion or membrane trace or not. You can also use the spacebar, which blends the last two sections you've been on. So if I go to 43, then scroll up to 44, and I press spacebar, these sections blend together. And this also allows you to sort of judge what is and is not part of your dendrite. Okay, I'm going to switch to this freehand tool to go really fast. So you should note this is not very good tracing, so do not make your traces like this, or else we will unfortunately have to take points off. So we continue like this, and if we've gone far enough up to where this protrusion is now, the neck is not connected to the shaft of the dendrite anymore. So as I continue doing my trace, and the second protrusion has come into view, so I'm going to include that, and I'm not going to trace that entire protrusion just for time's sake, but on an assignment or working with actual experimental tissue, I would go ahead and trace that spine by scrolling above it and also below it, because sometimes you'll come upon a protrusion that will seem like it attaches to the dendritic shaft and then goes away and does not do anything as you keep scrolling up. But if you scroll backwards, then you may see that it connects with an axon and makes a synapse. So almost done. This is a protrusion, covers a decent amount of sections. And at this point, I'm not going to trace the membrane any longer, but in an actual series, I would go ahead and trace that entire dendrite through the whole series to give me a nice 3D model of the entire dendritic segment. And as you can see, the dendritic protrusion is getting smaller, but it is still there. And if you miss a couple sections like this, once again, your protrusion will appear somewhat flat, and that is not desirable. We want to correctly model how the dendritic segment actually appears in the neuropil. And at this point, the protrusion is pretty much gone. I may just add in a little trace right here just for the 3D modeling, and I'll make sure it's within it. So to create the 3D model, I can go to the Objects drop-down menu, click List Objects, And I actually need to go to the series options really quick, so I'm going to go to Control O and go to 3D tab, and okay, so the Boston Mount surface is selected, and that's what you'll need whenever you want to create a 3D model of your dendrite. And the size seems fine. Top and bottom horizontal faces is fine. So I'll click OK. Then I'll go over to D03C, which was dendrite I was working on. I'll double click it, and I'll get this 3D model of the dendrite. So that is the short reconstruction that I did, and these are similar to what you'll be creating in class or in the actual Harris lab if you choose to stay on and work in there. Thank you. I hope this video was helpful, and have fun reconstructing.